Hi everyone. Yes, guys. What was the last topic that we have discussed, guys? What did we study in the last session? Activation functions. Okay. All right. Do you have any questions in that, everyone? Do you have any questions in that? Anyone has any questions? All right. Let me share the Google Sheet. Let me take that. All right. So in the last session, we have seen AMA 34. This one is batch. All right. Then let us have discussion on the last part. So in this last session, we have discussed this thing, right? We have discussed the activation functions, different activation functions, and the role of the activation function, which introduces the non-linearity in the data. Yes or no? So it introduces the non-linearity in the data. And due to that, it will be able to easily find the complex patterns in the data easily. Yes or no? So it will be easily able to find the complex pattern, and which is why we are using the activation functions. And these are the types of activation function and its ranges. We already have discussed this. Now it's time to discuss the next part. That is nothing but your that is nothing but your Just give me a minute. Yes, so let me create new um, sheet, this one. Let me rename this as second Feb, and this is of 25th Jan and first Feb, right? First Feb, correct. So we have, what do we have now is, yes, different hyperparameters, right? Or parameters that we have in our hand, and hyperparameters that we can change to increase the performance of the model. To increase the performance of the model, right? So neural networks require rigorous training, but what does it mean to train a neural network? What are the parameters that networks learn during the training? That it learns during the training, right? Or what does it mean train neural networks, right? What are the parameters that the network learns during the training? And what are the hyperparameters that you, as a network is designed, need to specify, right? So, what are the hyperparameters that you, as the network is designed, need specify before that, right? Now recall that models such as linear regression and logistic regressions are trained on their coefficient, right? The models such as linear regression and logistic regression are trained on their coefficients. That is, the is to find task is to find the optimal values of the coefficients to minimize a cost function. Neural networks are no different. They are trained on weights and biases. Neural networks are trained on, these networks are always trained on weights and biases, right? So in this segment, you'll be introduced to the parameters that you are going to learn during the neural network. And you'll also develop a broad understanding of how the learning algorithm works, right? So during training, let us take the figure so that you can understand it properly. So the figure that we have for the artificial neural network is, suppose, this one, right? So let's take this and let's paste it over here. Now, so during training, the neural network learning algorithm fits various models to the training data and selects the best prediction model. How this happens is, see, first of all, what will happen is, let's say, um, let's take a case of regression, right? In regression, How many neurons you will be having in the output? Regression. Output neuron for regression. How many neurons you will be having? Yes. Only one, no, for regression problem. Yes or no? Yes or no, guys? For regression problem, how many neurons you'll be having in the output? Only one, right? So, what I'm trying to say is, let's say, you're predicting this price of a, price of a car, let's say, or bike. What is this? Kilometer, HP, horsepower, multicolor, CC. Okay, so let's consider this is car, right? So you're going to fed this thing 23, 4, 6, 9, 8, 6, 1, 1, 6, 5, this row, right? First row, 90, 1, and 200. And this. So depending upon the number of features that you have, 1, 2, 3, 4, 5, 6, 7, you are going to, feed this to your model. You are going to feed this to the model. So there are several weights will be assigned, right? Then there will be weights in the hidden layer as well. This process will take place, right? And you'll get the output. Let's say price it is predicted for this training data is, let's say, for that car is 4 lakh, right? And actual price, this is predicted price. Actual price, let's say it is 3.75 lakh or 3.78 lakh, suppose. So what's the difference that you have? That will be error, right? So let me write down over here. Suppose predicted is, it is, 4 lakh and actual is 3.8 lakh, right? So the difference will be your error. So still it is making error of 20,000. Yes or no? Now, in order to reduce this error, what will happen is, see how learning process happens in this. It will, it will, uh, you know, it will, mm, yeah, it will go back. This is known as forward propagation. Like taking the weights, doing the calculation, assigning the weights to the hidden layer and doing the calculation over here. This is what is known as your forward propagation. Forward propagation. You can consider. And this is known as backward propagation. Backward propagation. Like going back and changing the weights, right? Changing the biases in order to just get closer to this predicted value, right? So we'll be we'll be updating weights associated with this because that is in our hand. In order to learn it properly, weights should be updated. So W1 new, W2 new, W3 new, W4 new, something like that is updated. This is also updated somewhat. And then suppose in the next iteration, you are getting the output as predicted is, let's say, 3.89 lakh, right? So it will come closer, obviously, because you are changing the weights, right? Changing the biases. Now this time error is 19,000 or 9,000, right? Again, it will go backward propagation. It will predict, change, update the weight, biases, and it will come again closer. Let's say 3.83 lakh. This is also 3.8, 3.8. This time now 3,000 error. So likewise, we have number of forward propagation, number of backward propagation, and one forward, one backward is known as an epoch, guys. Right? What do you mean by epoch? EPCOH. It is One forward propagation and one backward propagation is known as epoch. So if you ask me, how many epochs do you have in real case scenario? We have guys 500,000, 10,000, 20,000, such like number are like that epochs. So can you just imagine 20,000 epochs means 20,000 times it will be updated, forward, backward, forward, backward, forward, backward to just get the desired value. Are you guys getting this now? What do you mean by epoch, everyone? Right? Are you guys getting this, everyone? Yes? Correct. Correct, correct. So that's what we have. Then what we'll be doing is we'll be writing down. This is how that learning algorithm works, right? So your learning algorithm is kind of trained with a fixed set of hyperparameters associated with network with the network structure and some of the important hyperparameters to consider to decide the network structure are given below. Right? So we have number of layers, we have number of neurons in the input, hidden and output layers. We have learning rate, that is the step size taken each time we update the weights and biases of an NN. Then we have number of epochs, that is the number of times the entire training dataset passes through the neural network. Right? And the purpose of training the learning algorithm is to obtain optimum weights and biases. The purpose of training the learning algorithm is to obtain optimum weights and biases. Why we are interested to obtain optimum weights and biases? That form the parameters of the network, right? Now, you'll learn about hyperparameters such as learning rate, number of epochs in the upcoming segments. But in this session, we are going to focus on the number of layers and number of neurons in each layer, right? So let's consider learning rate and epochs afterwards. But let's consider only, we'll be focusing on the number of layers and the number of neurons in each layer. So the notation that you will come across going forward are 1. W means it is it will represent the weight matrices, entire weight matrix like W1, W2, W3, the transpose of that, right? That is a W matrix, weight matrix. B stands for bias. X stands for, guys, input. X represents the input. Then we have Y represents the crown truth label, and this P represents the probability vector of the predicted output classification. Right? So P represents probability vector of the predicted output for the classification problem. Right? And this H represents output of the hidden layers with appropriate superscript. Right? The output of the second neuron in the nth layer is denoted by, okay, I'll just write down output now of the second neuron in the, now this is somewhat complicated, but let's try to understand. Output of the second neuron in the nth hidden layer, right? Nth hidden layer means you will be having this input of the, this neuron of the input, input model, right? Then you will be having, you will be having uh, neurons in the hidden layer. Yes or no? These are the neurons in the hidden layer, right? And you'll be having neurons in the output layer, right? So suppose this is output of the second neuron in the nth hidden layer. Suppose we have n hidden layers. Consider these are the hidden layers: 1, 2, 3, 4, 5. 1, 2, 3, and up to n. This is the output of the second neuron. Output of the second neuron in the nth hidden layer, right? This one. It is represented by H2n, right? H2n. Now just remember this thing, guys. This is your notation. Even though if you, I mean, if you are understanding it, that's well and good. Even though if you're not understanding, that is also fine. Like this is not something which is very, very important for you. But anyway, this has lots of mathematics associated with that. So if you are good at the mathematics level, you should give it a try and become expert in this, right? So output of the nth hidden layer, second neuron, this one, that is H2n. So I'll just take this and I'll draw it. H2n. Are you guys understanding this now? H2n is what? Output of the nth neuron in the second uh, nth hidden layer, output of the second neuron in the nth hidden layer, right? It is represented by this. Okay, so let me just correct this. And last but not the least, we have seventh term, that is Z. And what is that, guys? It's a, it is represented as the accumulated input. Accumulated means W1x1, W2x2, W3x3 plus B, right? Accumulated input to a layer. So again, accumulated input, accumulated input to the third neuron of the nth hidden layer is Z3n, right? Accumulated input of the third neuron of the nth hidden layer. This is Z3n, right? Like this, we write down it like this, right? So let me take it and let me paste it over here. Just a minute. this one, right? So I'll be taking up this and I'll be pasting it over here. Right. Why it's not taking? ठीक. Now we have eighth term, that is bias of the first of the neuron of the third layer is represented as B13. Bias of the first neuron of the third layer is known as B31. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So bias of the first neuron of the third layer, this one, right? Can you just imagine how complicated it is going to be now? Yes, B13. Now you have to remember this notation. Anyway, if it is not possible for you, that is also fine, right? Correct. So I'll write down the superscript. What do you mean by superscript, guys? Superscript represent the layer number, the weight matrix connecting the first hidden layer to the second hidden layer, that is denoted by W2. It is denoted by W2 like this, right? Let me take this, let me paste it over here. And then we have 10, that is the superscript. Sorry, subscript now, subscript that represents the index of the individual neuron in a given layer, right? So the weight connecting the first neuron of the first hidden layer to third the third neuron of the second hidden layer. Now can you see this? Again, a little complicated. The weight connecting the first neuron of the first hidden layer to the third neuron of the second hidden layer, right? It is represented like this. Weight 3, 1, 2. This superscript, it is known as layer. So it is second layer. You can get it second layer. The subscript is known as individual neuron in a given layer. So if I write down 3 first, so weight connecting to the first neuron of the first hidden layer to the third neuron of the second hidden layer, right? That's what the idea is. Now, as this is little complex, you can imagine how the calculation will be, right? Now, excuse me. Now, having understood this, I'll just take down one figure and give it to you guys so that you can get an idea about the architecture of the neural network. Simple. The figure is just a minute, guys. S- s- This one, right? Now we are going to see assumptions. Like there should be one assumption. There should be some assumption. Then only, you know, we will feel easy to calculate the output. I don't know why ये image नहीं क्यों नहीं आ रहा है. Why we are not getting this image in this. If I just refresh this, I should get the image. Yeah. Do we have images over here? Correct. Don't have it. Mhm. So this is your image, guys, and it has the notation that we have. I just have given to you. That notation is there over there, right? So that's what the idea is. Chalo. What's the next part? The next part that we have is this. Hmm. Now, you might want to look at how the inputs of the first data x1 is represented. This will help you in answering the questions. So far, you have come across simple neural networks and have computed the output for them. But this is not the case with real world application. At times, the neural networks can be highly, highly complex, guys, right? And to complex and large, neural networks can be very complex and large. Therefore, you'll need some assumptions to make some, to make them understand, to make them easier to understand, right? So we should follow some assumptions. And what are those assumptions that we have? So why do we have assumptions? Because we need to have some assumptions because neural network is, you know, neural network is highly complex and large, right? Therefore, to or you will need some assumptions to make them easier to understand, right? Now let's move further with the assumptions part in the neural network. So what are the assumptions that we have? Uh, Assumptions for simplifying neural network, right? So, since large neural networks can potentially have extremely complex structure, certain assumptions are made to simplify the way in which information flows in them, right? So let me take one another diagram. Yeah, this is a diagram. So the image below shows the assumptions that we are going to discuss. So assumptions are see, to summarize, commonly used neural network architectures make the following simplifying assumptions. First is the neurons in an NN are arranged in layers, and these layers are arranged sequentially. Second is the neurons within same layer do not interact with each other. Third is the inputs are fed into the network through the input layer, and the outputs are sent out from the output layer, right? Then fourth is neurons in consecutive layers are densely connected. That is, all neurons in layer 1 are connected to all neurons in layer L plus 1, right? And fifth is every neuron in the neural network has a bias value associated with it, and each interconnection has a weight associated with it, right? Now, sixth is all all neurons in a particular hidden layer use the same activation function, and different hidden layers can use different activation function, right? But all neurons in a particular hidden layer uses the same activation function, but different layers can use different activation function. But in all or in a hidden layer, all neurons use the same activation function, right? So that is the assumption. Let us revise it one by one. All neurons in an artificial neural network are arranged in layers. These layers are arranged sequentially. The neurons within the same layer do not interact with each other. Right? Neurons in the same layer do not interact with each other, cannot interact with each other. That is the first assumption. Second assumption is the neurons are fed into the network through the input layer. Neurons are fed to the network through the input layer. So this is your input layer. This is going to be your input layer, right? And the outputs are sent to the output layer. Output are sent to the output layer. Output are sent to the output layer, right? And neurons in consecutive layers are densely connected. Neurons in the consecutive layer are densely connected. Neurons in the consecutive layer are only connected, right? So this one and this one cannot be connected, not possible. This one and this one, not possible. This one and this one, not possible, right? So neurons in the consecutive layers are only connected to each other and they're densely connected, right? So all neurons in layer 1 are connected to the all neurons in layer L plus 1. And then every neuron in the neural network has a bias value associated with it, and each interconnection has a weight associated with it. All neurons in a particular hidden layer use the same activation function. Different hidden layers can use different activation functions. But in a hidden layer, all neurons use the same activation functions. Right? On a hidden layer, all neurons use the same activation function. So all neurons in a particular hidden layer uses the same activation function, right? Different layer can possible. Suppose this is sigmoid, so this is softmax or tanh. That is possible. But all neurons in the same layer cannot have different activation functions. That is the assumption, right? So just go through this, guys. And if you have any questions, let us discuss that. If you don't have any question, we'll take a break. And this break will be of 5 or 7 minutes. A quick break to have my coffee, right? And after this, we are going to see the, summary part basically. And after summary, we'll be going to hands-on, hands-on session. Chalo. Go through this, guys, everyone. Yes, guys. Is it done? Do you have any questions in this? If you don't have any questions, let's have a break till 10:10. And I'll be sharing some files with you so that you will be able to. Hmm, MNIST dataset is on something which we are going to work on. Yeah, yeah. We are going to work on MNIST dataset, guys. So that is already available on your sklearn. So we don't need any dataset for today's hands-on session, right? Let's have a break. Okay, all right, guys. Let us have a look at the next part. So for the hands-on session, we guys are going to use Keras library, right? Keras, but uh, you know, um, yeah. First of all, I'll just introduce in this session. We will learn about high-level API Keras and how to implement, a neural network using Keras, right? And you'll also explore some best practices for training neural network. So if time permit, we'll also explore some of the best practice for training neural networks. That is dropouts and patch normalization. That is something which we are going to study, right? Simple. So, um, if time permits, we'll discuss this dropout and batch normalization. Now, in this session, we are going to deal with Keras. It's a high level API using TensorFlow. TensorFlow is something which we generally use while working with the, you know, convolution, any neural network, not only convolution, any neural network can be performed by using TensorFlow library. We are going to have implementation of neural networks using Keras. We'll see epoch. You already have seen that. Batch and overfitting and underfitting. We have dropouts and batch normalization as well, right? So as the main prerequisites of for this session, you must have a good understanding of the topics covered in the previous session of this module, right? Okay, so let us go back to the drive. And on your drive, we have day 34. Okay, 26 Jan. It's not something which we have done. This should be not 26 Jan, first wave, right? And let me create another folder as day 34. This is second Feb 2025. And this is also deep learning, right? And in that, let me create new collab notebook. And what we will require is okay, okay. ठीक है. Let's understand the Keras library. So to install Keras on your Jupyter notebook, if you're working on Jupyter notebook, you have to write down pip install Keras, right? If you're working on Jupyter notebook, if you're working in Colab, no need to write down that. And if you want to know the version of Keras, so you'll write down Keras dot underscore version underscore underscore, right? And Now that you need to have either Theano or TensorFlow in your system in order to use Keras. In order to use Keras, we need to have Keras is not defined. You need to install it then. You need to have Theano or TensorFlow, any libraries of it. So if you're working in Colab, you will not be, you will not require TensorFlow. You will not require TensorFlow. So we need to first of all, I think installation is not necessary for Colab, but I have done it. You need to import Keras first, guys. Import Keras, and then you can run this version of Keras that you have, right? So I'll comment this line. And in order to install, TensorFlow, if it is not there in your Jupyter notebook, you should write on pip install TensorFlow, right? Pip install TensorFlow. All right, that's what we have. Then there are six main steps involved in the building of model using Keras. I'll be giving you guys a summary of this thing. Don't worry. Um, but in order to work with the and creation of the data, you need to have a six stages, six steps. Let us start that one by one. Right? Let us start that one by one. So, uh, okay. This is what we'll do is I'll write down agenda over here. We have agenda in that I have data read and feature transformation. We are going to see that. Then Keras model, we'll see that. And then we'll see Keras training loop. Right? Now you have understood how neural network works. You know what is epoch, what is neural network, what is neuron, what is input layer, what is bias, what is activation function, what is hidden layer, what is output, right? You have understood that. Let us try to create a model, right? Let us try to create a model. So I'm importing the necessary libraries. I'm importing pandas as PD, numpy as np, from sklearn dot preprocessing. I'm going to import standard scalar, right? And then I'll be having part number one, that is import the housing data and do feature transformation. I'll let df is equals to pd dot read underscore csv. And I'll require housing data. It's not there. I need to just download this and I'll share this with you. Let me just have a look at this. Do I have housing data? House, housing data. Don't have that. This one. Right? I'll be sharing this file with you. So I'll be giving to you over here. Housing data.csv. This one. I hope this is the same file which we are interested to work in. Let's go and check this. H should be capital. Yeah, correct. Now, if you just check head of the data, we should have three columns over here. No, not this, not this. Just a minute, guys. Just a minute. I'll be just downloading this file and share this with you. Don't take this file. This is not something which you are interested because this is little advanced. You know, we want very simple model, not that much advanced. So I will be, you know, creating. Anyway, a lot of theoretical part is remaining, guys, but you know, we should not get, you guys should not get bored. So we are just having a practical part. Lots of practical part, or sorry, theoretical part is missing. We have not completed. So the file that we are interested to. House plus Keras file. And this is your data set. Yeah. I'll just upload it. House price data set. House price full one. This one. Correct. Yeah. And I'll just share the screen. Right. Let's see this. Let us see this. So if I just restart and run all, first of all, I need to, import the file. Let me copy path for this file. Correct. Yeah. So this is my data frame, guys. Can you see this? We have three columns only. And now it becomes our, the model should be simple and pretty much clean. So part two is create a model using Keras. So how do you create a model for this, everyone? So basically, you write down from TensorFlow import Keras, right? And then you write a model. So do you remember model creation step in machine learning? We are doing somewhat that only. Keras dot models. As you know, this sequence are this layers are sequential. Open and close bracket. Keras dot layers dot dense 2 comma activation is equals to sigmoid comma input underscore shape is equals to x dot shape of -1 comma bracket comma keras dot layers dot dense 1 comma activation is equals to linear, basically linear activation function I want, right? I'll be fitting my model. X is not defined. Okay. X is not defined. We have not defined X, is it? X should be defined, no, first. ठीक है. What should be the X then? Yeah, right. Before actually defining an X, or before we need to define X, what is that? It is basically X is equals to df dot copy, and close bracket, and we are going to remove target. Y is equals to X dot pop. I want to pop price, right? Only price will be there in the Y variable, and X will be df dot copy. Basically, what I'm trying to do is in X bedroom square feet living should be there, and in Y only price should be there. So I can do like this only, like this as well. Bedrooms and square feet living, and Y will be df of price, right? Then I need to perform a scalar transform of the input data. So X is equals to scalar dot fit underscore transform, that I'll pass X, and I'm going to perform log transformation of target variable, right? Perform log transformation because some variables are, you know, having a high range or high value. Some variable are having less value. So we'll just use a scaling for that. And for Y, there should be np dot log transformation is required. Anyway, that is something which we generally do it for all the columns out there. So I should define scalar equals to standard scalar, and we need to import a package for that. We already have that package. Correct. Now you can fit the model, right? Model equals to sequential. Anyway, you'll find it difficult in the initial phase, like how do you fit a model and how do you create a model by using Keras. It will be somewhat difficult in the first stages. X is not defined. We have defined X, no, now. It should be there. What does it say? Could not interpret activation function linear. Linear L is small, not capital, small. Dense is D capital. Correct. Hmm. Iterable. ठीक correct. There should be a list. In this list, we should close this. That should be there. Correct. So Keras dot model sequential, and this should be a list of all the, you know, um, layer you are creating basically, right? And then you have to define a variable, guys. Anyway, this particular library is not something which we are going to use, but you should know this. Model dot summary. Once fitting the model, you need to write down summary of the model. So in my first layer, I have 6 neuron. The shape is this. Parameters are 6. In second layer, I have only 7, 1 neuron. Output shape is this. This is input shape. These are the parameters. So total parameters are 9. Total trainable parameters are 9. Non-trainable are 0. What is this thing? We have not seen that, but you know, This is just a structure of your model. We have sequential two layers. Output should be two. Input is input is two, and then one hidden layer is there. Like that. We are just fitting a model, right? And then next thing is little tedious. We have to, you know, we have to define random init parameters. We have to define df random underscore init underscore params. In that we pass this w1 is equals to df dot variable df dot random dot uniform b1 is equals to df dot variable. This w2 is equals to v2 is equals to this, and I'm going to return the w1 b1 w2. So weights 2 and bias 2, right? This is the this is not needed if you are using Keras, no, sorry, TensorFlow. This is not needed, but for Keras it will be tedious, and then you have to create another forward propagation function. That is also something which will not be using while using with the TensorFlow advanced library. But since we are learning the Keras, we need to define this manually. But nowadays we don't define, right? So this is Z1 is equals to mathematical multiplication of x1 w1 plus b1, right? X1 w1 plus b1. X1 w1 plus b1. Then you have z1 equals to tf dot matmul w1 x1 equals to this, a1 is equals to sigmoid. We need to define h1, which should be tf dot math dot sigmoid z1 z2 is equals to tf dot matmul w2 comma h1 plus v2 h2 equals to z2, and you are going to return v2. Then after this h2 is equals to z2, and then we are going to return h2, and there will be part 3. There will be a part 3, that is training loop. We are going to train a loop, so we'll create a function, define train x comma y comma w1 comma b1 comma w2 comma b2, and then y underscore true is equals to y with small y with tf dot gradient tape as tape y underscore print for. This is also something which we are not going to use. See, if you are using Keras, you have to define this thing, right? But for TensorFlow, no need to define, right? So y prediction loss function is something which you are going to define. This is your loss function. Very tedious task, and it will start to train, right? Yeah, before this, let me write down my compilation of model. So model.compile. I understand this will be a bouncer for you, but you don't have any option. What is Adam optimizer? What is optimizer? We'll see that. Loss. I just write down optimizer is equals to Keras dot optimizers dot sgd. I don't want to give learning rate as of now, so I'll not give. Loss is equals to mean squared error, correct? And metrics, is it even needed? No needed to pass. No need to pass this. Comma should not be there. No error. Right now, we are going to run this one. Now we will be actually doing the gradient calculation. So we are going to print this one. Guys, this library is no one uses this library nowadays. Keras. It's a high-end API. No one uses it. We have TensorFlow. Then print trans. Tape is not defined. No needed, no. Why we are defining tape? It should be directly GW1 W1 comma GB1 comma GW2 comma GB2 is equals to A dot gradient loss comma W1 comma B1 comma W2 comma B2. Then we are going to print the gradient for first layer weights are this dash n comma GW1 dot numpy and gradient for second layer weights are this dash n comma GW2 numpy. Then this should be print. So we close from here. G is not defined. Okay. G. In this thing, define train with TF dot gradient as G should be there as G. And then y plot is equals to forward dot prep x dot w1 x w1 b1 w2 and b2. So we have four parameters, correct? X w1 b1 w2 b2, correct? Five parameters are there. Loss should be there here. Yeah, this print statement inside the function. These are the inside your function. All should be inside this function. This print statement should also be inside. This one inside, 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 inside. Right? Let's do this now. And after this, we need to write down gradient descent. Again, this is something manual calculation. Nowadays, we don't do this. Gradient descent, right? Learning rate I'm defining 0.2. Weight dot assign underscore sub into LR into GW1, right? B1 is this, correct? W2 is this. Print should be there, no? Print. Yes. I can write down new print statements like this before returning the. Yes, correct. So I can take this. I can take this. I can paste it on here. Here it should be new updates, and then print the updated first layer weights are slash n comma w1 dot numpy close bracket, print the updated second layer weights are slash n comma w2 dot numpy and close bracket, print correct this one, right? So this is just a function, guys. Now we need to fit the model not fit on x and y on values comma epochs is equals to 10 comma batch underscore size is equals to 12. Yes. Sorry, 32. After this, it says values are not different. Dot values. Sorry, why not values? Now it is starting, right? Now you'll, after some session you will be having a look at, by using TensorFlow we do not need to write down this. We do not need to construct the architecture like this manually. It was old school days. In old school days we used to do like this. Nobody does this like that. But you should have an understanding of the background. That's the reason we are just having a look at this. Mm, So this is the epoch. Can you see this? In the first epoch, we have given 10 epochs, mean 10 forward and backward rounds will be there. So in first epoch, loss is 153, then reduces to 0.1927. Can you see this? Losses decrease. And by using this neural network model, I want to predict what? I want to predict X and first row. So this is my row. This is of what? Of my data. This is my data. It will be predicted. Right? Means basically all the values of X are predicted. Right? So that's what we have. Sure. So this is all about your Keras, guys. Keras, model building using Keras. Now just go through this. Anyway, if you're not understanding, we don't have any problem. We have high end, uh, you know, this library. Which one? TensorFlow, right? So we'll be using that. So at the high level, we have to follow the steps, guys. What are the steps that we have by Keras library? We'll just write down that, right? So first of all, what you need to do is you need to let's write down here, guys. By using Keras, if you guys are interested to build a model, what are the stages that we have seen? A very rough idea, right? So there are six main steps involved. What are those? Six main steps. I'll just write down over here. Then you can take a note of this. Hmm, okay, correct. This is what we have, right? So I should write down there are six main steps involved in building model using Keras. Right, first step is load the data. So we load the data, load underscore data. Then second is define the model. We write down nn underscore model equals to sequence bracket. Then we'll write down nn underscore model dot add. Then 35 comma input underscore dimension. This is 784 comma comma activation function. You could write down which is equals to value, right? And here is an example of 35, what it denotes. Step number three is compile the model. So after we have defined the model, we need to compile the model, right? After we have defined the model, we need to compile the model. And during this step, Keras uses Keras uses Keras uses the backend libraries efficiently represents the above described model for training and for prediction. So we need to specify the loss function, the metrics, as well as the optimizer in this state. So we should write down nn underscore model dot compile loss is equals to categorical underscore cross underscore entropy, comma optimizer is equals to Adam, comma matrix is equals to accuracy. And then we are going to fit the model. nn underscore model dot fit train underscore set underscore x comma train underscore set underscore y comma epochs is equals to 10 batch underscore size is equals to 32. Simple, very simple. And then we are going to evaluate the model. After fitting evaluation, the model is done. Need to write down scores underscore train equals to nn underscore model dot evaluate train underscore set underscore x train underscore set underscore y times print slash n percentage s percentage dot to f percentage this in an underscore model dot metrics course underscore name 100. This is training. Similarly, test score will be there. Scores underscore test, right? And then we are going to make the predictions. So predictions is equals to nn dot nn underscore model dot predict test underscore set underscore x. So these are the steps involved in building the model in Keras, right? You must have observed that we need not write any code for the forward and backward propagation as we did not implemented the neural network using TensorFlow. In TensorFlow, it is very easy. It is automated. In TensorFlow, we need to write down the forward and back propagation, but uh, in Keras, it eliminates all those efforts of doing the forward propagation back, right? So ideally, what I'm trying to say is, I think I have told you in other ways. If you are building a soul model, a whole and soul model by using TensorFlow, right? Because this is Keras only, this is TensorFlow model, this one, right? This is tf.reduce.mean. So what I was trying to say is, by using TensorFlow, you need to define forward propagation and backward propagation. This is by TensorFlow, guys, right? My bad. This is by TensorFlow. TF is done, no? We have imported TensorFlow as TF. I think I have told you the other way around. Correct, correct. See, we have imported TensorFlow as TF. If you just see, we have imported TensorFlow as TF, right? So this model building that we have seen, uh, is of TensorFlow. So what I'm trying to say is, this is, we need to write down forward propagation and backward propagation, which is quite hectic. But I told you that Keras we don't use, no, we use Keras, right? Because Keras is something which is helpful for us, which reduces, eliminates all those efforts of writing down this whole code, entire code. Which one? See, uh, can you see this? This is your step of model building by using Keras, right? So Keras, you don't need to write down anything. Simple. Created model. This is something of TensorFlow, right? So in Keras, you don't need to write down anything. You don't need to write down what the forward propagation calculation, like what happens It is x1 w1 plus x2 w2, right? Plus b1, something like that. We don't need to write down that. Correct? So in your, this uh, by using Keras, you just need to write on model.compile, optimizer, Keras optimizer, and SGD. For TensorFlow, I should write down to understand this. This is model building using TensorFlow. Can you see this? Very difficult. But this is model building using Keras. This one. Only this lines of code. So you need to write down, remember this using Keras. And in the industry, we follow this thing, right? We don't specify what is happening, what is not happening over there, right? Then this is TensorFlow, this is Keras, this is TensorFlow. So model training using Keras. This is model training using TensorFlow, right? Now, this is model fitting, correct? Model prediction. The rest of the things are similar, right? So we are kind of comparing the TensorFlow and Keras. Simple. Nothing difficult in that. Correct. Are you guys getting this now, everyone? Are you guys getting this? Is it clear for you? Yes, guys. Is it clear? If it is clear, we'll stop here for the day because I'm not feeling good today. We'll be having you know, only 2 hours of session, and in next session there would be practical discussion. So 1 + 7, 8, 8th Feb, you guys will be getting a real intuition of how the neural network works. So we are going to see the feed forward network. I'll just write down the syllabus and we'll stop here. Feed forward network, feed forward procedure in neural networks, right? Then, uh, then we are going to see introduction to neural network. Part 2, we'll see backpropagation in neural network and neural network implementation using Keras. Yeah, we'll see that. Sure. All right, then we'll stop little early because I am having fever. Let's stop here for the day, guys. If you have any questions, you can ask. Otherwise, we'll just stop here for the day. Yes, any questions, guys? Any doubts? Anything? Topic, very, very important topic. Today's topic, I understand practical part is something which we are seeing only first time, but you will get comfortable with the Keras library. Like how do you fit model? Then how do you know, compile the model? Easy steps are there.
Yeah, hi people.
Yeah.
So the in the GUI portal, so the last classes, I think it's showing us today. So for next week, you will be getting a mail, or it will be.
Okay. You'll be getting this mail only, no?
Okay. So usually we'll go to that portal and we'll join. So
Correct, 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 correct. I think you guys, I'll just ask them.
okay.
Just a minute. Let me ask them to join. Correct. Good question. I just got a confirmation from them. You guys will be getting in the portal itself. There will be additional sessions section. Right beside that, there will be learning path. And you guys also will be getting an email before next session, right?
Okay. Thank you.
Don't worry about it. All right, guys.
Sir,
Thank you.
sir,
Yeah.
sir, will you consider that extra sessions attendance also, sir?
Consider.
Guviti, you are saying that your team will take extra sessions to complete the course, right?
Yes, right.
Yeah. Will you consider that attendance also for the attendance policy, sir?
Yes, yes. That is your regular session only, not extra session. We have not covered syllabus, no.
Yes, sir.
So it's very important for you to attend that.
Yeah, yes, sir. Yes, sir. Yes, sir. My doubt is, will you consider that attendance or not? That's the name.
Yes, that's what I'm saying. No,
Yes, sir. Yes, sir.
important. We should attend that. That is not extra session. That is your syllabus only, first of all. So don't consider that as the extra session.
Okay, sir. Okay, sir.
Chalo. Thank you. Bye, everyone.